Today's topic is about clustering algorithms, K-means, DB-scan, and hierarchical clustering. Introduction to clustering. Clustering is an unsupervised learning technique used to group similar data points together without predefined labels. The task of grouping data points based on their similarity with each other is called clustering. Purpose of clustering: to find natural groupings in data, discover underlying patterns, and simplify data for analysis. Types of clustering algorithms: partition clustering or K-means clustering, hierarchical clustering, density-based clustering. K-means clustering. Unsupervised machine learning is the process of teaching a computer to use unlabeled, unclassified data and enabling the algorithm to operate on that data without supervision. Without any previous data training, the machine's job in this case is to organize unsorted data according to parallels, patterns, and variations. How does the K-means algorithm work? Choose the value of K, select K data points, each of which represents a cluster centroid, assign the rest of the data points to their nearest cluster centroids, reposition the cluster centroid after each data point assignment till it's the average of all data points in that cluster. Repeat step 3 and 4 till there are no more changes in each cluster. After the final iteration, this is how the clusters are formed. Density-based spatial clustering of applications with noise. Clusters are dense regions in the data space separated by regions of the lower density of points. The DB-scan algorithm is based on this intuitive notion of clusters and noise. The key idea is that for each point of a cluster, the neighborhood of a given radius has to contain at least a minimum number of points. Hierarchical clustering. It is a popular method for grouping objects. It creates groups so that objects within a group are similar to each other and different from objects in other groups. Clusters are visually represented in a hierarchical tree called a dendrogram. There are main two types of hierarchical clustering: agglomerative clustering, division clustering. Agglomerative clustering. Initially, each object is considered to be its own cluster. According to a particular procedure, the clusters are then merged step by step until a single cluster remains. At the end of the cluster merging process, a cluster containing all the elements will be formed. Division clustering. The division method is the opposite of agglomerative method. Initially, all objects are considered in a single cluster. Then the division process is performed step by step until each object forms a different cluster. The cluster division or splitting procedure is carried out according to some principles that maximum distance between neighboring objects in the cluster. Applications of clustering: market segmentation, anomaly detection, social network analysis, image segmentation, bioinformatics. Conclusion: K-means, DB-scan, and hierarchical clustering are powerful unsupervised learning algorithms that group similar data points without labels. Choosing the right algorithm depends on your data characteristics and the specific analysis goals, enabling effective and insightful clustering across various applications like market segmentation, anomaly detection, and image analysis. Thank you.